Hello there, this is Alana Tuckey, and these are going to be the lecture videos for section 8.6 of Math 131, which is modeling with rational functions. So in this section, we're going to run into a few different applications. The first is one that we've seen before, which is the percent application. So let's see how it works with this example. We have the following table shows the number of doctoral degrees granted altogether and to male students, both in thousands over many years in the U.S. So here are the total number of doctoral degrees earned. And over here are the total number earned by males. Doctoral degrees are PhDs, right? Professors. All right, so M of T is a good model for the number of doctoral degrees earned by males at T years since 1970. And D of T is a good model for the total number of doctoral degrees earned altogether. So that's the total. Now we're going to come up with a percent function. Now percent, remember that we learned back in another section of chapter 8, the percent, basically to create that function you have to take your small subgroup function, which in our case would be M of T, and divide it by your total, which in our case would be D of T. But that's always going to be a decimal, right? Because if you take a small number like, say, if I look back at the table, 89 and I divide it by 206, I'm always going to get a decimal. So the way to solve that problem is to always multiply by 100, and it'll turn that decimal into a percent, which is what you're actually looking for. All right, so then let's look at what our two functions are. Let me type those up. All right, so we have 0.04 t squared minus 0.427 t, times 100, plus 26.675, and then over the 0.09 or 0.029 t squared minus 0.329 t plus 32.353. As a matter of fact, let me put that right up here. All right, so when you multiply by 100, what you're really doing is multiply by 100 over 1, right? Because 100 is in the numerator. So the way this actually is going to work is that all the three numerator coefficients are all going to get multiplied by 100. And that's going to cause their decimal point to shift 2 places to the right. For example, this 1 was in the hundredths place, but you multiply by 100 and it turns it into the ones place. Right? That same thing will happen here. So that instead of being before the 4, it'll be right here after the 2. So it'll turn that into a 42.7. And then here it'll move it after the 7, so it'll become 2,667.5. All right, there's our percent function. Part A is done. Next, is that function increasing or decreasing, and what will that mean? Good question. All right, so we wouldn't know necessarily if that's increasing or decreasing just off the bat. So let's grab a calculator. Go to y equals, clear out the old, and type in the new. Now, if you have an old calculator, like an 83, you're going to have to put parentheses and type in the functions. So it was 1.4, oopsie. 1.4 for x squared, 4, there's my 4, and then x squared plus or minus whatever it was, minus 42.7, etc., etc. All right, so you'd have to type all this, minus 42.7 x plus 2667.5, close that parentheses, then divide, and then type the rest. Left parentheses, and then type everything else. So that's the old school way to do it. Let me type it up 1 second. Oops, there we go. I've got it all typed up. And then you would close your parentheses over there, right? So that's how you have to do it the old school way. It's really kind of hard to see if you've got it all typed in correctly and everything. The new school way to do it, let me clear this out. So I would go alpha F1. I'd pick numerator over denominator, number 1, and then you type in here. So that way it looks just like you expect it to look. X squared, oopsie, except you have to type the X button. Hold on. There we go. X. There it is. And kind of use your arrow keys to move around. Plus 42.7. 0.7, oh my goodness, 0.7 x, and so on. So let me type that up 1 sec. Oops, and that was a minus 42.7. Sorry, I didn't notice that until I went back and looked at the problem. But when you have it written like this, it's so easy to see that it matches what's on the paper, right? When you type it with the old method without using that alpha F1 option, it's really much harder to see that it looks like you expect it to look. All right, so there's our function right there. Now if I press graph right now, it's probably going to make no sense. Let me do a regular window. Yeah, so the calculator is working. The function is being graphed, but you can't see any of it because it's all a mess. So let's go to the window and think about this for a second. X for us was time. So if you look back to your table, time 0 is back at 1970. All right, well, we go to 39 alone in this table. So how about we go to like 50 or 100 or something like that? So how about 0, 1970 to 50? How about that? And then scale, who knows, make it 5. That way you go 5, 10, 15, 20 for your tick marks. And then your Y min 0 is fine. Your Y max is a percent, right? So what's the highest the percent could ever be? 100. So let's start with that. If it's too big, we can always come back and make it something smaller if the graph is really tiny. And then I'm making 10. That way go 10, 20, 30, 40, and so on. So let me press graph now. And look, there's the percent graph. It is decreasing for sure. All right, so let me grab a picture of that and we can put that right on the paper as a quick sketch of what's going on. Oh, it looks like we're going to need a sketch of it anyway in the next problem. All right, so are we increasing or decreasing? We are decreasing. So that means the percent of doctoral degrees that are earned by males is going down, right? Which probably means the percent earned by females is going up, right? Hypothetically speaking, right? Next, find T when P of T equals 50 using a graphical method. What does it mean in this situation? Okay, so we have our P of T graphed here. Let's go back to the y equals, and they want to say when it's equal to 50, so you type 50, enter, and graph it. And lo and behold, it's on the screen. Good. You have to have the intersection on the screen to be able to find it. So hit second calc, which is above your trace button. Hit number 5, which is intersect. Blue curve is my first curve, enter. The red curve is my second one, enter. For guess, you can just kind of move your cursor closer to the intersection if you so desire and press enter. And there it finds it. So I'm going to grab that picture. I didn't need to keep the other one, but this one says using a graphical method, so I'm actually going to put that in. There we go. All right, now what does it mean? So we just found that it's 37.33. So 50%, because 50 is Y. Y was your percent model, right? So 50% of doctoral degrees granted in the U.S. were to male students, right, to males in what year is that? 1970 is your base year. So add 37 to that and you have 2007. There you go. All right, I'm going to stop this video here. The next video will cover the next problem, which is about the mean. So I'll see you here then.